Hello again, class. We're continuing on with dilution, and this lesson is going to be a little bit shorter. You can see I got a new background again. It's a place I've already done a presentation before. I was in the bathtub another time, but I was facing the other way, so now you can kind of see the big window back there and a few more plants. You know, nice fresh air, gives me some good oxygen, so my brain actually works. That's wonderful. So let's get into the lesson here. We're looking at cereal dilution. You notice it's not spelled the same as the cereal you eat. However, you could dilute cereal in this way. In fact, I happen to see my wife do this all the time with the Lucky Charms, where for some reason the marshmallows keep getting diluted, meaning there's fewer and fewer in the cereal, and it's very disturbing to me. But I digress. Let's think in terms of chemistry here. So what is cereal dilution? Well, it's where you take something you want to dilute and you continuously use the solution you make to make the next one. So you start with one solution, you make it, and then you take some of that solution and make the next one. And then from the next one you take some and make another one, and so on. And so you're continually diluting down until you get the least concentrated solution. So you can see that happening in this picture down here. Now this one is just focusing on beads, but you can think of it in terms of liquids. So we start with mostly blue beads, we add some white, and it gets less concentrated, and we keep going. So taking one from the one we just made, some from the one we just made, add some more, and so on. And we do the same thing with a regular solution where we are just adding more water every time. So you take some from here, add some water, now you've got this. Take some from here, add water, now you've got that one. Okay, so that's what's going on. So not a long lesson, but you just follow along with the calculations. So with this is one we normally do as a lab, and unfortunately we can't do that with the whole COVID thing going on. We can't even get into the lab. So we're just going to do the calculations that go along with it. So to start off the lab, I'm going to have you make a solution with a specific concentration and volume. So in this case, it's the iron 3 nitrate, and I want a 50 ml solution with this concentration. So you're going to actually take solid iron 3 nitrate and add it to 50 mils of water, and it will turn into the solution that we want. Okay, so that means we're going to have to calculate the mass of the iron 3 nitrate. After that, you're going to use the solution we make here and dilute it to that concentration. And then once you dilute that one and make it, then you dilute to this one. And then you use this one to make that one, and so on. So you can see how it's a serial dilution because you're doing one after the other after the other. Okay? So I'm going to show you the calculation for the first one here. I'm going to show you the calculation to do the first in the dilutions. And then what I want you guys to do is do the next three calculations. This one, and this one. And I want you to, maybe take a picture and send it to me showing that you've done that calculation. Okay? So without further ado, here's question 1. So our given is the concentration and the volume. So right away you're thinking, hey, I'm using this triangle. But of course we want mass. And you notice in this triangle, there's no mass there, right? It's nothing. But this triangle has mass. There it is. So we're going to have to get to that triangle. So if you notice, if you can find moles, you can bring it over to the second triangle over here and figure out the mass. And how do you do that? Moles times molar mass. So I've got the molar mass down there. So how do we do this? It says concentration times volume. So I'm going to multiply my concentration times my volume. So that's what I'm doing right here. So this one you can probably do in your head. Cut 50 in half, you got 25. So that's how we get that one. Okay, and the liters cancel. And then from there, you take the moles that you calculated and multiply them by the molar mass. And once you do that, the moles cancel, they're gone, and you're left with grams. So this is telling me I need to get 0.05 grams of iron-3 nitrate, weigh it out, get the mass, and then dissolve it in 50 mils of water, and I will have a solution with that concentration right there. Okay, so now I'm going to take this solution that I made and I'm going to dilute it. So that means I have to take a little bit of that concentrated solution to make the new one. So how do I do that? Well, the new one I want to make has this concentration and this volume, and actually it's not that, it's actually a 1 there. So let's just change that right now. Okay, so there and there. Okay, so now we have the new volume and new concentration, and we also have the old one, the one we just made, which is that stock one right there. Okay, so we start out just using, and we're only going to be using this triangle for the next bunch of calculations. So you can see we have a volume and a concentration. So these two ones, because they're both new, we're going to multiply them. So that's what I'm doing right here. Multiply them, and we get the moles. You can see liters cancel out. Once you have moles, go back to the triangle. We have a concentration hanging out right here. So moles divided by concentration are going to give us the volume. Okay, so that's the volume of the stock solution we need to take out, but that doesn't give us a 10 milliliter solution. We have to dilute it. Those 5 mils right there, or the 0.005 liters, have the same concentration as this. So we got to dilute it. So if you notice, we're actually cutting it in half, right? We're making a 0.25 mole per liter solution. So if you think we need to have 10 milliliters, I already have 5. How much water do I need to add to it? 5 more milliliters. But of course, I've got the calculation down here rather than just counting on my logic. So the water we mix is the one that is going to give us our dilution. So you can see here, the volume of the water equals the total volume you want minus the volume of the stock. So we're subtracting this from the total. We want 10 mils. So we're subtracting that from it to get the total volume of water to add. And so down here, I've got the calculation in liters. But of course, if you want to make it more easy to remember, there's your milliliters. Okay, so 10 mils minus 5 mils, so 5 mils of water. So you're going to mix 5 milliliters of the stock with 5 milliliters of water, and it will be diluted to the concentration you want. So this calculation that I just went through, this last one, is the one I want you to do for the next 3. Only this time, your stock, so the old, is going to end up being this one, and your new is going to be right here. And it's going to just keep going. So then this will become your old, and this will be your new. And then this will be your old, and that'll be your new. So 3 calculations, and then send them off to me. All right? Thanks. Have a good night.